Hi, I'm Karen Stever with Griffin Greenhouse Supply's GGS Pro Group. We provide technical advice for professional growers who are Griffin customers. Today I want to talk to you about water alkalinity and how that affects the pH of peat-based growing medias, potting soils. After this webinar, if you have any comments, suggestions, or questions, please give us a call at the number and extension shown, or you can shoot us an email. Factors controlling the soilless media pH are four main factors: what the soil mix components are, and of course, the lime charge is included in that, and that is a big one. The second major factor is the alkalinity of the irrigation water, and we're going to delve into that. The third is your fertilizing, whether it's acid forming or base forming will influence your pH, and that is a feature that we will use to help stabilize our pH. And the fourth is the species effect, which comes from the plants themselves. We can see that in this experiment done by Doug Bailey and his associates quite a few years ago now. So they started with soil at pH 5.9 and planted all these different plants in it. And then we see how those plants on their own drove the soil pH. Plants in some cases work against their own best interests. So water pH was not listed as one of the factors in controlling the soil pH in my previous slide. And in fact, the pH of the water really has negligible impact on the pH of soilless media. However, the water pH is critical when you're in hydroponic production, where the water is actually the growing media. Water pH is also very important in pesticide performance. So pesticides have a range that they are stable at, and outside of that range, they may decompose rather quickly. I'm going to spend just a minute describing other water parameters that we measure. Alkalinity in your water test is actually a measurement of primarily the dissolved bicarbonate in the water. Hardness is often confused with alkalinity, but it measures something totally different. Hardness measures the calcium and magnesium primarily in the water. pH is a measure of the hydrogen ion concentration in the solution. Bicarbonate is a base and hydrogen ion is an acid. So those two interact to form a buffering system shown here, where the hydrogen ion can interact with the bicarbonate, that's HCO3, to form carbonic acid. And in water, carbonic acid largely decomposes into water and carbon dioxide. So in providing that buffering capacity, our bicarbonate is used up. We're going to revisit this equation when we talk about reducing our water alkalinity. So now that we've defined the terms, I want to show you why the alkalinity vastly overrides the pH effect in having any influence on the soil media pH. Let's just say we have a water sample that has an alkalinity of 153 and a pH of 6.0. That's be a pretty reasonable irrigation sample. To compare the amount of each of these ions in a liter of water, we're going to calculate in terms of number of molecules. That's millimoles or moles. So for 153 parts per million, the bicarbonate concentration is 2.5 times 10 to the minus 3 moles per liter. The definition of pH is listed here. In our example, at pH 6, the hydrogen ion concentration, by the definition, is 1 times 10 to the minus 6 moles of hydrogen ion per liter. 10 to the minus 3 is significantly larger than 10 to the minus 6. That's 1,000 times difference. So specifically for our example, the bicarbonate concentration is 2,500 times more concentrated than the hydrogen ion in our water sample. In fact, pH is always going to be lower than the alkalinity, which we measure in parts per million. So no matter what the specifics of your water are, the alkalinity will override the pH. So we won't worry about a high pH of the water. We're only going to worry about what the alkalinity of our water is and make adjustments as needed so that we can grow our plants at a proper pH. And this slide shows basically the break points in what we would consider low, moderate, and high alkalinity. Low alkalinity water has very little buffering capacity, and the fertilizer then has an overwhelming effect on the pH. That's a fact that we want to use to control our pH, right? We can use an acid fertilizer or a base fertilizer. At moderate pH, we consider our water to have good buffering capacity. And again, we'll use the balance of an acidic and a basic fertilizer to maintain the soil pH in the region we want. High alkalinity water has really excessive bicarbonates. The fertilizer alone is not strong enough to overcome that high alkalinity. And so our solution is to inject acid to reduce the alkalinity down into this moderate range. Even without a water test, there are signs of high alkalinity water often while you're growing the plants. The most obvious sign is iron deficiency. Due to high pH, the iron becomes less soluble, less available to the plant, and they tend to yellow out like this. Interveinal chlorosis, it's called. We see it on petunia, begonia, snapdragons. Chrysanthemums are notorious. Lots and lots of plants are subject to high pH iron deficiency. So this table shows us how you can correct your alkalinity, neutralize the alkalinity so that you're down in the moderate zone using either tech-grade sulfuric acid or battery acid, which is a lower concentration. Whichever you use, you cannot mix the sulfuric acid directly with any fertilizer stock containing calcium, but you can mix it with all the non-calcium fertilizers, 21-5-20, 20-10-20. Always mix your fertilizer up, put all of the components in, and then add the acid slowly with mixing between each little bit that you add. Wear safety glasses and there will be no issue while you're mixing that up. The table on the previous slide was lifted from our 5th edition of the Technical Reference Guide. In Chapter 10 of this guide and in the appendix, there is a lot of information about the acid-base properties of fertilizers, as well as water and corrections for different pH and salt issues. So tons of information on water and nutrition, as well as all of these other subjects. If you're interested, you can order that from your Griffin rep. Thanks for your time. If you have any comments, questions, please send them to our email or give us a call at the extension shown here.